All right, so lesson 2, we kind of learned the basics of how you name organic compounds. And now we're going to learn about different scenarios because organic compounds can get really complicated. And so looking here, what do you notice that's different about these carbons? Well, we've never dealt with what's called a double bond. Do you see this double bond right here? Double bonds are very common, and so we have to indicate that there's a double bond if it is there. So when there's a double bond, the name of the compound, rather than going from ane, it gets changed to ene, okay? So what might have been called like butane becomes butene. I don't know why this isn't writing all of a sudden. Butene, if it had, if that was the name of it. So you just change the ending to ene if you see a double bond. So let's name this compound. This is all one branch. You might think that this is like the main parent and this is a branch, but you just find the longest line of carbons. And this is all one line. These are all connected together and there's no branches coming off of that, of carbons. So this is the parent chain right here. There are 3 carbons. And so going back to table 2.1, the prefix for 3 is pro, okay? So we're going to name this propene, okay? Because ene indicates that there is a double bond, and pro indicates that there are 3 carbons, okay? But you also need to show where the double bond is. And so we're going to call it 1-propene because the double bond starts on carbon 1. You don't have to call it 1-2. Even though this double bond is between carbon 1 and carbon 2, you start at the first one and you know that it continues on. So this is called 1-propene. This is just a reflection of that. This would be named the same thing. It's just flipped over. So this is carbon 1 with a double bond there. So it would be named the same thing. So let's just work through some more examples here. These are coming out of your problems from this lesson. So let's name this here. So this has no branches in it. This is one long chain of carbons, right? There are no like branches coming off or anything in a weird way. So we need to name this. So what is the prefix for 6? Going to table 2.1, the prefix for 6 is hex, right? Hex. So we're going to name this hexene because there is a double bond right here. And then we need to show where the double bond is. And it's coming off of carbon 2. So its name is going to be 2-hexene because that's where it's coming off. You don't need to say 2-3. You know that it's going to continue on to carbon 3 right there. So you just show where that double bond is. All right, let's name this one. This is kind of strange because the ordering starts up here, but let's see. This is our parent chain right here. And how many carbons do we have here? We have 7 carbons. We have no branches coming off in some weird way. So we just need to name the 7 carbons. The prefix for 7 is hep. Hep. So we're going to name this heptene. Heptene because of this double bond right here. And then we need to show where it's coming off. You might want to call it 4-heptene. But actually, when you read it from the beginning, you want to show the lowest number first. And so it's not 4-heptene. It's actually 3-heptene, okay? Because it starts at carbon 3 and continues on to carbon 4. So 3-heptene. All right, so these are my little notes. So I'll explain it to you in just a second. Look at this scenario here. We still have this parent chain. There are no branches here, but we have 2 double bonds. 2 double bonds, okay? So we still name the branch like normal. So how many carbons do we have? We have 6. The prefix for 6 is hex, okay? So we're going to name this, normally you name it hexene, right? But we have 2 double bonds. 2 double bonds. And so we kind of like do this weird thing where we say hexadiene. Di means 2. And so you're saying, okay, there are 2 sets of double bonds. And so the name will be hexadiene. That di just means there are 2 double bonds, and the ene means double bond. And now, we need to show where those double bonds are. There's one starting at carbon 2, and there's one starting at carbon 4. And remember, you don't have to name the second part of it. So it's going to be called 2, 4 hexadiene. This is showing where those double bonds start on each one. And the di just means that there are 2 sets of them. Okay, let's name this next one here. Again, we have 2 sets, so we need to take note of that. But let's see, are there any branches here? Let's just circle our carbons. There are no branches here. So we need to name this. There are 8 carbons. The prefix for 8 is oct. Oct. So normally we would name this octene. But since there are 2 sets of double bonds, we're going to name it octadiene because there are 2 sets of double bonds, and then we show where they start. So one starts at carbon 3 and one starts at carbon 5. So the name will be 3, 5 octadiene. Okay, let's look at this one. Do we have just a regular parent chain? Well, when we look at these carbons here, this is our parent chain right here, right? And then this is called a branch. So we need to take care of that branch as well. Let's name the parent chain first. So there are 5 carbons here, 5 carbons. So the prefix for 5 is pent, okay, pent. So we're going to name this pentene, but there are 2 sets of it. So we're going to name it pentadiene. That di just means 2. And now we need to show where the double bonds are. There's one double bond coming off of carbon 1 and going that way, and one coming off of carbon 3 and going that way. So we're going to name it 1, 3 pentadiene. And now we need to name this branch. So that branch, if you notice, it's a CH3. So going over to our table 2.2, which one of these is CH3? It's a methyl group, right? CH3 if you look right here. And so we're just going to name it methyl. But you also need to show which carbon is it coming off of. It's coming off of carbon 2, right? That branch is. So it's going to be called 2-methyl 1,3 pentadiene. I know this is kind of like a lot of information. That's why I'd love to help you out with this. So now again, let's circle our parent chain. This right here is our parent chain of carbons. We're just circling those carbons. So it looks like we have a branch right here of a CH3 group. Remember that CH3 is called methyl. Okay. We have a branch right here. That's also CH3, so it's called methyl. And then we have a branch right here. This is 2 carbons, right? 2 carbons. So what is it called when you have 2 carbons here? When you look at this picture, you see how there are 2 carbons right here? That's called ethyl when you have that. So we're going to name that ethyl. Okay. So now let's go ahead and name the parent chain. There are 6 carbons, and remember that the prefix for 6 is hex. So we're going to name this hexadiene because there are 2 double bonds. And then we need to show where those double bonds are. There's one coming off of carbon 1 and one coming off of carbon 4. So 1, 4 hexadiene. The ene means that there's a double bond. So we've named the parent branch, and now we need to name all of these branches here. And you actually see how ethyl starts with an E and methyl starts with an M? You go in alphabetical order. So E comes before M, right? So we're going to name the ethyl group first because alphabetically E comes before M. So that would be, it's coming off of carbon 3, right? So 3-ethyl because it's coming off of carbon 3. And then we have these 2 methyl groups. One is coming off of carbon 2 and one is coming off of carbon 5. Okay. And there are 2 methyl groups. This is a long name here. So 3-ethyl is naming this part right here. 2, 5 is showing you where we're talking about here. And then they're both methyl. And so we say di for 2, 2, 5 dimethyl. And then 1, 4 hexadiene. So this is a big name here. Okay, so that just gets all smushed together. 3-ethyl, 2, 5 dimethyl, 1, 4 hexadiene. You should feel so smart. You should give yourself a pat on the back. I know it's like a lot of words to sift through, but the more you practice, the more you're like, okay, I do kind of understand. It's making sense on what we're doing, but just keep it up. Okay, so now let's look at this one here. How are we going to name this? This is going into a circle. Do you remember what we name things that are in a circle? We name it cyclo. So we put cyclo in front to make sure that you know that it connects. And then you just count the carbons. 1, 2, 3, 4, 5, 6. The prefix for 6 from that chart over here, remember that 6 is hex. Hex. This is going to be called cyclohexene. Ene because there is this double bond right here. Okay. And then we just need to show where it's coming off. If you notice on this one, it's kind of confusing because they don't number it for you. So which carbon is it? Is it carbon 1 or carbon 2? Well, basically you can number it yourself, and you kind of want to start, if you can, with that double bond. So we'll just call that one carbon 1, carbon 2, 3, 4, 5, 6. There are no branches of other carbons. And so the name will be 1-cyclohexene to show that coming off of carbon 1 is that double bond. Okay, next one here. Let's name this compound. So if you notice here, this right here is our parent chain right there. So see these carbons going like in that circle? So remember that when you have a circle, you put cyclo in front. And then how many carbons are on this parent chain? 1, 2, 3, 4, 5, right? So the prefix for 5 from this chart right here is pent, okay? So we're going to name this cyclopentene because there's a double bond. And then we need to show where is that double bond coming off? Well, it's coming off of carbon 1. You see how it's between carbon 1 and carbon 2? And so we'll call it 1-cyclopentene. Are there any branches of other carbons on this compound? Well, there's one right here and one right here. This is just a CH3 group, so it's called methyl. And this is also a CH3 group, so it's called methyl. So there are 2 methyls, so it's going to be called dimethyl because there are 2 methyl groups. One is coming off of carbon 1 right here, and one is coming off of carbon 3. So 1,3 dimethyl, and then 1-cyclopentene. All right, so let's look at this next problem in your lesson. If you notice there's something new here, there's a triple bond happening right here, a triple bond. So remember that when you have all single bonds, the name ends in ane. When you have a double bond, the name ends in ene. And if you have a triple bond, the name will end in yne. And we pronounce it ine, like ine. So ine. So we just need to change the name ending to ine and then name everything else like normal. So let's find the parent branch of carbons. So here is our parent branch right here, our parent chain. And we can count those carbons. There are 5 carbons. And so the prefix for 5 is penta or pent, as we can see. Hold on, let me share this tab. The prefix for 5 is pent. And so the name is going to be pentine, right? And we need to show where that triple bond is. So remember, you name it starting at the beginning of the triple bond. So the triple bond starts at carbon 1 and goes over to carbon 2. And so the name will be 1-pentine. And then we need to name this branch right here. We need to include that branch. If you remember, this is called methyl because it's 1 carbon and 3 H's, and that's the name for methyl. And that, so we'll name it methyl right here. That methyl is coming off of carbon 3. And so the name will be 3-methyl-1-pentine for this one. Okay, so for the next problem, what do you notice here? There's probably a few things that you should notice. First of all, we have another triple bond. And so I'm going to go ahead and write down that the name ends in YNE. We know that because there's a triple bond. Now let's find the parent branch. Again, it's right here. So what is the prefix for 8? 8 carbons. If you look right here, the prefix for 8 is oct. Oct. So the name will be octine. And we need to show where that triple bond is. It's between carbon 2 and carbon 3. And so we're going to call it 2-octyne because you only need to name the first part. Now, are there any branches? Yes, there is a branch right here. And then I'll do a different color for this one. There is a branch right here. Okay, they're different. This branch is just a CH3, which is called methyl. This branch is 2 carbons and 5 H's. 1, 2, 3, 4, 5. Yeah, 2 carbons and 5 H's. So going over to table 2.2, let's see. Actually, I need to scroll down to table 2.2. Hold on. Going over to table 2.2 right here, 2 carbons and 5 H's. That would be ethyl. See, there's 2 carbons there, and if you add that up, that's 5 H's. So ethyl is the name of this group right here. So remember that we want to do this in alphabetical order. So E comes before M. So we'll name the ethyl group first. We'll say ethyl. And then remember, we need to show where it's coming off. So it's coming off of carbon 4 right here. Do you see how it's coming off of carbon 4? And then the methyl group is coming off of carbon 6. So we'll name the methyl group. Oops, hold on. It's supposed to be in alphabetical order. So actually, the 4-ethyl should be at the beginning. 4-ethyl. But we want it to be in alphabetical order. And then 6-methyl. 6 comma. That's supposed to be a comma right there. Because it's coming off of carbon 6 right there. And then I think there are dashes in between, but it should look something like this. 4-ethyl, 6-methyl, 2-octyne for the name of that. And then the last problem here, what do you notice about this? Well, it's a circle again. And typically we name those starting with cyclo, right? And so according to our old rules, we would name it cyclo, and then there are 6 carbons here. Remember that when it's got those like corners, each corner represents a carbon. And so you can also look at it like this. Well, they don't actually show it again, but it really is like a carbon here, or carbon here, or carbon here, carbon here, like that. But it's like shorthand to write it way quicker. So every time that there is a corner, it represents a carbon. So we might name this cyclohexene, right? Or something like that, or cyclo, because there's 6 of them. But when you have this specific type, this type is so common that it has its own name. You notice how it has 3 double bonds, and it's like every other line is a double bond, every other line. This, when you have a hexagon like this, with every other one being a double bond, it's called benzene. It's such a common thing that we have its own name for it, benzene. So all we need to do, we've named this part. This part is called benzene. So we just need to name these groups over here. They are all methyl groups, because remember that methyl is the name for CH3 from that table 2.2. There are 3 methyls, and so we need to show where they're coming off. They're coming off of carbon 1, carbon 3, and carbon 5. So we're going to name this 1, 3, 5. Hold on, I need more space here. So 1, 3, 5, trimethyl benzene. Tri means 3, right? There are 3 sets, and they're at carbon 1, carbon 3, and carbon 5. Trimethylbenzene. So that concludes lesson 3. I know that was a lot, but hopefully it kind of gives you a grid. And remember, when you look at the multiple choice, look at the name ending, and if it ends in oct and it doesn't have 8 on that main branch, you know that can't be it. So kind of look at the multiple choice options to kind of get a good gauge for it. And then if you have any questions at all, I'm really happy to help you. Just send me a text.